So I want to talk a little bit about detection engineering today. And just to kick it off, I want to set the stage a little bit of what do I mean when we talk about detection engineering. This is a very oversimplified definition of this, but when I think about detection engineering, this is kind of what goes through my head. Like first, like I need to detect a thing, whatever that thing may be. How do I get the right data, the right telemetry? Is that an EDR agent? Is it some tool that allows me to look at email like Symmetry or Sublime talked about earlier, network sensors, whatever. From there, we define the detection logic. And then I think that the key things are testing and verifying to challenge your assumptions, right? So you like write a rule, you pat yourself on the back, you hope it works, and then run off into to go do the next thing, and that's what a lot of people do. Maintaining capabilities as threats evolve, and retiring capabilities when appropriate. I think the biggest thing that folks miss is they just sort of ignore those last three steps. So that's really where we wanted to focus on today in this discussion, is talking about how do we make sure that, how do we know our rules work? How do we make sure that they continue to work? How do we make sure that we don't break them later on? How do we maintain them because techniques change or new versions of operating systems come out or whatever, and we need to make sure that we can maintain those capabilities. And how do we make sure we don't have tons of detection logic just sitting out there consuming resources and making noise that's actually not doing us any good, right? If over 3 years you get a bajillion false positive hits off of a rule and you've never had a legitimate one, then maybe we just need to get rid of that thing and decide that it was never a good idea to begin with, right? So immature detection engineering practices cause a lot of problems, and I just want to enumerate some of those really quickly. First and foremost, like, can you look across your environment and say, can we detect this thing, right? Can we get this technique, whether you're looking at MITRE techniques or you're looking at a blog post from the DFIR report or wherever, and you want to know, like, can we detect these things? Do you have the capabilities to go through and one, just like look that up, right? In some way, shape, or form. Can you go and see, do we have coverage for this MITRE technique, and what sub-techniques do we have covered, and so on and so forth? Or do we have coverage for running run DLL this way, right? If you don't have it mapped to a MITRE technique necessarily, can you search for it in other ways and be able to answer that question? And if the answer is no, how long have we been blind to this tactic, right? And it may be that you've never had a detection capability for this, but there's also situations where maybe somebody made a change to a piece of detection logic that broke your detectors. So can you tell when that happened? Do you know how long you've been blind? Can you measure that? Do you know how long back you need to go hunt for this activity in your environments to be able to feel confident that you didn't miss anything important? How are you going to handle these questions if the answer is no? How bad is it, right? Or does this rule still work, right? That's another thing that comes up a lot. I wrote this rule 2 years ago. It hasn't fired. That's great. Does that just mean I've not been hit by this technique, or does my rule suck, right? Do we need to go and challenge these assumptions and go back and take a look at that? And then I think another big one this is a huge one that folks miss all the time is, I'm the world's best detection engineer, and I'm so smart, and I wrote this like ultra complex rule, and I put it in there, and now my night shift analyst gets a hit on that, and now what do they do, right? Does he know how to respond, or can she go and look at this alert and know what steps to take, what information she needs to gather, how do you escalate this, so on and so forth. So having a rule in place in a lot of cases is just like that first piece of the puzzle, right? And then the next one is who made this rule change, right? So let's go back to these scenarios. Somebody changed something and it broke. Somebody put this new piece of functionality in there and we don't know why it's there. It's not broken, but we just don't know like who made this alert, so who can we go and blame it on or ask these questions to? You need to be able to track these types of things. And really all this comes back to the solution for all these things is writing detections as code, right? To be able to maintain these things. Another big one is, will this rule cause a false positive flood, right? So I've got this new rule, I put it in place, I tested it here locally on my system, it works great. It detects the exact technique that I'm going to test, but is it going to cause some sort of false positive flood? And raise your hand if you've ever written a rule that accidentally fired on any new process creation. Like, I've done that. And as it turns out, when you're monitoring tens of thousands of endpoints, there's a lot of processes that get created all the time. So Bobby Boucher's mom was onto something, right? ClickOps is the devil. So we want to get out of going into our SIMs or going into LimaCharlie and using the UI for all of our detection work, right? So that's the approach that we've been taking since about 2018, 2019, is really making sure that everything we do is not really done through the UI, right? We can use the UI to go click around and do things, but ultimately anything we do is going to be done as code, and LimaCharlie's platform does an amazing job at allowing us to do that. And really the ultimate goal that we want to achieve with this when we zoom out is not just having detectors as code for the sake of like storing things in GitHub instead of going around and clicking in our SIMs or LimaCharlie for everything, but we really want to be able to track requirements from the requirement to the deployment of those rules into our client systems. And if anybody here has ever gone through a SOC 2 audit or anything like that, and you've got an engineering team, that's one of the big things that they're going to look for is every commit you make into your main branch, right? Every push into production, they want to be able to track those changes back to a hard requirement that was put in place by your product manager, right? And so we're looking at this and like, why wouldn't we do the same thing for our detections? Why should we have our detection engineers just like pushing stuff into our detection pipelines without being able to really map back to like, why is this thing here? Why does this exist? And whose fault was this? Like, who decided that this was a smart thing to look at and use our time on? This also, you can build this program to also enforce coding and documentation standards, right? So going back to the example of you've got a new rule, you've got this thing you want to detect, but you want to make sure that you don't have your detection engineers just YOLOing rules into prod, and you're equipping your analysts to be able to do a good job of investigating and responding to any alerts that happen in off hours or when your detection engineers are not around. So you can use these types of processes to enforce and make sure that whatever standards that you put in place are going to be enforced before they do it. And finally, the detectors as code allows you to reap all the other benefits of source control, right? So version history, I want to know every change that's ever been made to this rule for the history of that rule. I want to know who's changed it when, why, how. You can attribute those changes to the people who do it. If you screw something up, you can roll back to the last version of that knowing that that'll still be there, and you can make fun of your colleagues who don't know how to use Git, which is always fun. And finally, verifiable capabilities with unit testing. So if you've been a software developer and you're doing it in a mature way, you know that anytime you write a new function or a new API or something like that, you need to have this unit testing. That way, before you push anything into production, you have a way to automatically test it to make sure it's doing the things that it's supposed to be doing and it's going to achieve those basic functionalities. So we can do this as well with detections. We should never push something into our production environment without knowing that it's not going to break our detection capabilities. That way you kind of have those roadblocks in place. That way if somebody does make a typo, it doesn't destroy your ability to detect a capability. So that's sort of the background and the goals that we want to achieve with this. So I'll talk about the way that we've approached this and some of the lessons we've learned along the way. Again, we've been doing this for a long time, and it all sounded great the first time we did it. And then we learned about a lot of things that aren't so great, and we fixed those over the years. So we do this that way you don't have to. So this is a very high-level overview of the way that we view our detection lifecycle, right? So starting at the top left, you get a new detection issue. So whether it's somebody on our incident response team who finds some new technique that they've never seen before, and they say, hey, I want to make sure we can detect this thing. Or one of our offensive security team members reads some cool blog and comes up with this new idea, and they start tinkering around with something on these red team engagements, so on and so forth. Have the ability for really anyone on your team to be able to submit an idea, right? And you have to kind of quality control those types of things, but you want to be able to have these ideas flowing in very freely and map those coverage gaps, right? And you have to enforce some standards that we'll talk about there as well. Next, you go and develop the detection logic, right? So whatever language, YAML, JSON, SQL, whatever, build out this detector development. You want to test these things, and ideally when you're testing them the first time, you want to be able to build out an environment to go and simulate these attacks in a way that mimics real-world adversaries. But at the same time, you also want to be able to build unit tests. That way you don't have to go and build a VM or a virtual environment and run Caldera or Atomic Red Team every time you make a change to these things, right? Because that becomes massively inefficient. So test it once the hard way, and then capture that data. That way you can test it over and over again the easy way. And then finally, deploying and monitoring. Like I said, deploy it out there, put it in production, see how it behaves, figure out those edge cases that maybe you didn't think about these false positive conditions that are going to crop up, so you can go and put those tunes in. And sometimes those will lead to new ideas, right? So a lot of times we'll get an alert, and as our team's investigating it, there's another technique that's used in concert with that same intrusion vector. And we say, hey, this threw one alert in this attack chain, but this could have thrown 2 or 3 or 4, right? So we can feed right back into that cycle. Or tuning requests, or people just deciding this rule sucks and we're tired of seeing these alerts all the time, let's turn it off and get rid of it, right? So, phase 1, new detector issues. This is an example. We're sadists, so we make our people use Jira, and we'll have people put these in here, but we do have a template for these types of issues, right? So we try to make it easy. We used to have this long list of requirements. We would want a description of the technique, references, MITRE attack things, but then we also wanted, example attack chains and sample commands of how you could reproduce this behavior. And, predictably, everybody's like, I just can't be bothered, right? So I'm not going to do that. So we really simplified that down and said, okay, just give us a description and a link to some resources that we can go and investigate it more. Ideally, put some MITRE techniques in there if you want to, but otherwise our detection engineers can go figure that out. And we want to curate those ideas. And also, very importantly, we used to do this only with like new detection ideas, and we found going back to being able to track all the changes from the ideas to production, putting in tuning requests as well, right? So any change to a rule in production has some Jira ticket associated with it. That way we can track all these things. And if you're a Jira and GitHub user, you can do smart commits, right, where you can link the two, and all your commits have the Jira issue as the prefix to your commit comment, and it'll show up right there in Jira. That way you can see all the commits, and vice versa. You can link backwards too. So we never, this wasn't in scope for our SOC 2 audit when we did that, but we feel like if we ever had a SOC 2 audit of our detection engineering program, then it would pass muster pretty well. So first and foremost, again, encouraging folks to get those ideas into your team. I think the discussion earlier about threat-informed defense was great, and that's probably a much more mature way of kind of designing how you prioritize things. But we're big believers also in just getting ideas out there, right? We want to pull those things in because some people have really bad ideas, but there's also some really creative things that come through that way. Second is detector development. So that's not too small. This is an example. So we put together detector templates, and these are template files that are in our GitHub that everyone has to use in order to submit these detections, right? So this is what it looks like on our back end. We have a lot of metadata. First and foremost, a detector name and ID, a status, and that's a tag that we use internally to say this is active, or this is in testing, or this is archived, right? So that way we don't necessarily delete old rules. We'll keep them around in archive mode. That way we can go back if somebody tries to do the same thing later and see that it already exists and didn't work for whatever reason. Some other metadata. So we have an MDR portal thing that gives our analysts information on what to do if you see this. What are the false positive cases? What are the true positive cases? And what do you need to do for these things? And any other sort of notes that we want our team to be aware of if somebody's reviewing this. Then of course the detector logic and unit test. So some lessons learned here, using metadata fields that will easily be visible to analysts. So back in the day everybody would have to go into GitHub to see this stuff, which is not all that helpful. And then we learned that particularly in LimaCharlie, this is a LimaCharlie rule, you can just slap a metadata field into the response section, and then it'll all be visible in the alert, and you can display that pretty easily. So that was a nice lesson learned. The other one is don't use tweets or whatever they're called nowadays as your reference points, because those tend to disappear and do weird things, and then your analysts are pissed off because they can't find what you were talking about, right? So using good, solid reference material that has a lower likelihood of disappearing into the abyss at some point. And then testing. So this is something that I think is particularly cool. One of the things we have to do, right, is make sure, does it detect what you want it to detect? Does it not detect the things that you want it to not detect? And is it resilient to evasion tactics, right? So if I just start throwing carrots in the middle of all my command line strings, is it going to defeat our detection? Or if I use like IWR instead of invoke web request for a PowerShell command, is that going to avoid it? So thinking of all these sort of evasion tactics and making sure that we put test cases into it. And the other thing that we found, it used to be you would like go and put one of these rules together, put it into a test environment, and then, like I said, you run Caldera, you run Atomic Red Team, or you simulate some sort of attack here, and then you'll get some feedback and you can do it. And what we really tried to do is do like you do for software engineers. We really want to shrink those feedback loops because it massively increases productivity for our team, because you don't have to wait 10 minutes for a build to push everything into production for it to work. You don't have to wonder if your syntax is right. So LimaCharlie is a great tool. I don't know if you guys have heard of it. It's got a lot of APIs, and one of those is the replay API. And what the replay API allows you to do, if you've ever been in the UI and you've gone and like written a rule and then tested it against an event, there's an API for that. So what we do, you can see here starting on line 132 here, is we put verifiers, which are effectively unit tests that will run against every detection anytime that they get built, right? So you give it a name, and then you'll just give it a JSON list of events that will run against them. And this is literally just copying a LimaCharlie event, flattening it into one line and putting it on there. And then we tell it whether this should fire an alert, true or false, right? And when we build that, it will go through and test those. If it fails any of those unit tests, then it won't go into production and it'll kick back an error. So that was great, except that would also cause frustration, because our team would go and build this, they would do a merge request, and then they would have to go back and recommit the code, and that caused frustration too. But VS Code allows you to write extensions. So if you're able to learn JavaScript, you can write a VS Code extension to do a lot of this unit testing right here in the UI. So that's one of the things that we build internally, is using that LimaCharlie API. We pull out the detection logic and go through each of these unit tests to go and test them, and you can just run that right in your VS Code window before you commit, before you push anything up, so you know if it works. And so that's what's happening here in the output window down at the bottom. You can see we've got a list of verifiers here, and this is running through all of these to check whether or not they work. And it'll throw an error if not, and it'll tell you this isn't going to do it. And another lesson learned, going back to the alert storms, creating a generic false positive rule that is by default in our template now has been massively powerful, because it's super easy to write a rule that, again, fires on every network connection or on every new process event, because you did a or instead of an and somewhere or something, and it passes all your detections, because it does detect those things, but it also detects any other process. So creating these, you'll see the first one there is called the LimaCharlie generic false event, right? And that's just like an event in LimaCharlie that says like soteria test as the command line arguments, and if that fires on something, then something's wrong, right? So that has saved us countless times from having to deal with thousands of alerts coming out of nowhere. And then the last piece is like getting it into production. So you've wrote this rule, you've done all this testing, it works, and now we got to get that out into deployment. Again, using the tools that the GitHub gives us for developers, and the things that we've learned by going through SOC 2 audits and talking to other software engineering teams. Verified commits, so you can make sure that all your developers are signing your commits. That way, if somebody were to get into to GitHub and try to commit something without your key, then it would flag. There's a whole lot of nightmare scenarios. Like, that's kind of the least of my worries if that happens, but it's good to know, right? Smart commits, again, being able to map all your commits back to your JIRA tickets. That way, you know this commit is tied back to this requirement that was submitted by Paul on this date. Doing code review, so we've got. We talked about making sure that the code works, but by having a two-person review process enforced in GitHub, where nobody can go and push anything into the main branch without having review, is how we enforce the documentation standards, right? So making sure that there is useful notes in those note fields for our analysts, making sure that all that metadata is in there the way we want it to be, and it's not just going to be a mess and create other issues. We haven't found a way to automate that sort of logic yet, so having your teammates go through and look at that and make sure you're not committing garbage is super helpful. Again, using that unit testing, so using the same verifiers that we talked about on the last slide, you can then have that go and take place during the build process. That way it makes sure nothing goes into production without passing those tests. And then from there, you can automate the rest of the deployment. And all of this is done, or those last two steps are done via GitHub Actions, which is super, super powerful and makes it easy to run all these things. So putting it all together, the way we look at it, and this is maybe a bit more complex, but you start with some sort of threat intel. Your threat intel team, your offensive security submits some sort of idea into your Jira project. Detection engineers will look at that and they say, hey, this is a great idea. I'm going to commit this into GitHub, create an issue branch for that. That way, you're not messing around in your main branch, because that's always a bad idea. And when you create that issue branch, that will map back to your Jira piece, but it'll also allow you to do a pull request to pull that into production. Unit testing happens. Then once that passes, your other detection engineering colleagues can go take a look at that. They can approve that pull request. GitHub Actions will merge it to main, hitting that LimaCharlie API, and all the rules are deployed to everywhere. And then you get a Slack message everywhere along the way, saying that this passed or failed, right? So that's how we do it. There's a lot of different ways to do it. I think that it's certainly not the only way, but it's been massively effective. So that's what I got. But I do want to say just real quick that this all started with us back in about 2018, 2019, when some of our team members wrote a white paper called Detections as Code and started kind of mapping out how we were going to build this out. So I talk about this a lot, but I'm not really the person who implemented most of these things. So David Burkett in the back of the room was one of the co-authors of that first paper, and Brandon Poole was not here. So really appreciate all the work they did while they were with Soteria, massively impactful and still having an impact 4 or 5 years later today. So that's what I got. And I was going to go through and do a quick demo of the VS Code plugin and kind of show how that works, but I can jump off. Okay, yeah, we can do that. Let's see. So, this way? Yes, this way. All right, so this is, in the VS Code window, this is a pretty basic example of an Office document spawning a shell, right? That's a pretty standard rule, and one that I'm going to mirror my screen, that way I can talk and not have to break my neck while doing it. All right, so basic detection for an Office rule that looks for any sort of Microsoft Office document spawning a shell. So we've got all of our metadata in here, some overview, normal behavior, yada, yada, yada. But more importantly, we've got our verifiers down here that are going to test it. So running a plugin, oops. If you run a plugin, you can see this one here, run verifier test, hit that, and it will say that it's running the verifiers off of these. And it's just going to, again, loop through all of these, hit the LimaCharlie replay API, passing it the event or series of events that are in this event field, and evaluate it and determine whether or not it should come back. So the easiest way to demonstrate how this would work is if we change this to true, like this shouldn't fire, but we're going to maybe mistakenly change that. And then we want to go ahead and run the verifier test again. It'll loop through all these again, and it should just pop up and say false here. And this, if you've done any detection engineering or DNR rules in LimaCharlie, this probably looks familiar, where you test this and it'll tell you how each operation worked out within LimaCharlie, right? So, this one was true, this one was true, and all these return false, and therefore your rule sucks, and try it again, right? So it's useful from that perspective, but I think the biggest piece that we come across, right, is if somebody's messing around with a rule and you accidentally do you've got an and it should have been an or something like that, right? So again, we can, just run this VS Code plugin, and it's going to fail like right away, right? Because this rule is not the correct way. So it just allows you to go through again as a detection engineer, instead of having to go through the process of deploying these rules up into LimaCharlie and run all these different commands and try it. It's just a really quick way of testing these things. And I have thought about open sourcing this, by the way, and I would really like to, but I haven't figured out a way to make that useful, because in order for this to be useful, you'd have to be using our templates and all the other stuff that, like the build pipeline that we're using. But if anybody wants any more information on this or to see the code of how this works, I'm more than happy to share it. I just haven't been able to figure out a way to open source this in a way that makes it actually useful to anybody else besides us. So that's all I got.